Hey Algebra 2 students, today we start Chapter 4 and we are going to start reviewing quadratics and factoring and FOILing. So before we get to our actual notes today, I want to recall what it means to FOIL. So if you look at these problems on this slide, okay, the directions would be simplify. Remember that when you have two quantities right next to each other, that means multiply. And within these quantities we have two terms. So the acronym FOIL stands for first, outer, inner, last. And so we multiply. X times x gives you x squared. X times 2 plus 2x. 3 times x plus 3x. And 3 times 2 plus 6. The final step when you are simplifying this problem would be to combine your like terms. Remember that a like term is the same variable raised to the same power. So the 2x and the 3x are like terms. And when we add those like terms, we add the numbers in front and leave the variables alone. So let's try again. We have a problem x plus 3 times x minus 3. So we have to FOIL. So I multiply x times x, which is x squared, minus 3x plus 3x, and minus 9. Again, final step here of combining like terms. I have a negative 3x and a positive 3x. Those cancel each other out. I'm left with x squared minus 9. Now, a problem you're going to see showing up over and over and over again in these sections in this chapter is the quantity x plus 4 squared. If you were tempted to make this x squared plus 16, go in the bathroom, turn off the video, look in the mirror, and yell at yourself. It is not x squared plus 16. We can't distribute an exponent over addition. What this means is the quantity x plus 4 times x plus 4. And again, to simplify this, you have to FOIL. So you get x squared plus 4x plus 4x plus 16. So the simplified version, x squared plus 8x plus 16. So you can see that if you try to distribute that exponent, you are missing that middle term of plus 8x. Again, this problem is not going away. So when you see a quantity squared, you need to write that quantity out times itself and FOIL. Okay, so that's just to recall that we FOIL, multiply all those terms. The real lesson for today is to talk about factoring. Factoring is essentially unfoiling. So we start in the standard form and we want to go back to the factored form. Okay, again, this is standard form. All the terms written in order. This over here is factored form. So when you see directions of factor, that means write it as a quantity times another quantity. So let's review from Algebra 1. This first slide we are going to focus on factoring three terms. Count them. 1, 2, 3. Okay. In all of these examples, the leading coefficient, or the number in front of x squared, is a 1. So when we are factoring three terms where the leading coefficient is 1, we follow a similar process every single time. First, we look at the sign of the last term. If the sign is positive, that means that the signs inside of the factors are the same. The same how? That comes from the middle term. They're the same, and this means they're both positive. So I can start by writing x plus times x plus. To figure out what goes in this last spot, I think about the factors of 12. 1 times 12, 2 times 6, and 3 times 4. I want to see when I add those set of factors, which set adds to 7. Well, it's not 1 times 12. 2 times 6 when added is 8. 3 times 4 when multiplied is 12, and when added is 7. So this factors to x plus 3 and x plus 4. A common question is, well, what if I wrote it as x plus 4 times x plus 3? That's okay, because multiplication is commutative, so the way that you write those factors does not matter. Let's take a look at number 2. X squared minus 2x minus 8. Take a look at the signs. The last term is negative, which means the signs of our factors are different. One is positive and one is negative. Now we have to think about the factors of 8. Okay, so I have negative 1 times 8, 1 times negative 8, negative 2 times 4, and 2 times negative 4. So when I factor those, I want to see which of those adds to the middle term, which is negative 2. Well, it's not these first ones. Negative 2 plus 4 is positive 2, so I'm close. That doesn't work. It's these last two. 2 times negative 4 is negative 8. When added is negative 2. That means the 4 has to go in the negative spot. The 2 has to go in the positive spot. So there you go. You could keep practicing, okay? Or you could multiply it out to see if you did it right. There are always options. Number 3, we're going to start to do some of this in our head now. What multiplies to negative 18 and adds to negative 9? Okay? Well, let's check it out. If I have negative 18, that means my signs are different. X minus, x plus. Factors of negative 18 are negative 1 and 18, 1 and negative 18, negative 3 and 6, 3 and negative 6, 2 and 9. So I start thinking about those and I realize none of those add to negative 9. The answer here is prime, which means this is not factorable. All right, here we go. Factor. X plus, x minus, because the last term is negative. That means signs are different. What multiplies to give you negative 45 and adds to 4? Factors of 45, I'm thinking 9 times negative 5. Sure enough, I'm correct. Let's do it again. X plus, both positive because the last term is positive, and so is the middle term, means signs are the same and they're both positive. Multiplies to 16 and adds to 8 is 4 and 4. And last on this slide, I've got x minus and x minus. Well, let's talk about those signs. Last term is positive, which means they're the same. Middle term is negative, which means they're both negative. So what multiplies to positive 9 adds to negative 6? The answer is negative 3 and negative 3. Here are 6 examples of factoring 3 terms when the leading coefficient is 1. All right, one more topic for today. We're now going to talk about factoring 2 terms that are being subtracted that can both be rewritten as something squared, better known as dots. If you can follow that pattern, 2 terms as something squared that are being subtracted, it factors to a plus b and a minus b. So let's take a look at some examples. First thing I notice, I have 2 terms. I ask myself, are they being subtracted? Yes. Can I rewrite them both as something squared? Well, x is already squared. Does something squared give me 16? And the answer is yes. X squared minus 4 squared. So my pattern is x is the a term, 4 is the b term, x plus 4 times x minus 4. Again, number 2. 2 terms being subtracted. Can I rewrite them both as something squared? Yes. This factors to x plus 3 and x minus 3. Number 3. 2 terms being subtracted, can I rewrite them as something squared? Yes. Then it follows the pattern x minus 10, x plus 10. Notice that I wrote the minus 10 first and the plus 10 second. It doesn't matter. Okay, well check this out. What if I added a number 4? X squared plus 25. Okay, 2 terms not being subtracted. Can I use that pattern when I have 2 terms being added? The answer is no. This doesn't factor. There's nothing else I can do here except for write prime. So the important thing about this pattern is that it only works for 2 terms that are being subtracted that can be rewritten as something squared. All right. Well, here we go. We've got some video examples. The first 2 say FOIL. I want you to multiply on these first 2. 3 through 8 ask you to factor. Notice 3 terms, 3 terms, 2 terms. 3 terms, 2 terms, 3 terms. How you think about factoring those problems changes based on the number of terms. All right, tomorrow we're going to take it a little further. Thanks for watching my video, and I'll see you in class.